So we have looked at the ramps, but we also want to understand the variability and uncertainty in generation. The variability and uncertainty in generation is mostly because of the different meteorological conditions that might have occurred during that point of time. So what do we have to do is we have to analyze the weather data, we have to analyze insolation, we have to analyze all the other meteorological parameters that could actually possibly influence the amount of generation. So we usually identify the weather patterns that correlate to the high or low generation periods, particularly lulls. And then we use this in order to predict what is going to happen in the future or how many number of customer outage minutes we might actually see in the future periods. So for example, if you look at the 2009 dust storm, this was a massive event where we had a very low amount of generation, and it existed for a few days actually. So what we did, we tried to understand what happened because of this dust storm. So we could see that there was a huge lull that because of this dust storm, but what we saw was there was this region across New South Wales where there was very low amount of insolation. And then we used those meteorological data set in order to understand what was contributing to it. So for example, we analyzed the weather and the synoptical charts. We could see a huge low pressure across that region at that point of time. That was one of the main reasons why we have a block of low insolation across New South Wales. But and then we used this data in order to analyze what was the number of hours we actually saw the consecutive lower amount of generation. And it's not surprising that even though the dust storm was just over Sydney, but the impacts were across other different regions. This was because the aerosol or the dust in the atmosphere was transported by the winds to the different parts. Then just analyzing these case study events, what we do is we understand whether there are going to be similar sort of meteorological events in the future, and then we use it for predicting the future lull periods.